Alright, let's talk about a very exciting theorem called the intermediate value theorem. So take a moment and jot that down. So what this is saying is if a function is continuous between a couple points, it's going to take on every value between those 2 points. So I know this sounds extremely obvious. Alright, another way of putting this is if it's continuous, it's going to hit every point in between. So these are the 2 points we're talking about. We call the x values a and b, and then f of a and f of b are the y values. So if it is continuous, all right, if and only if it is continuous, then it's going to hit, it's going to take on, it's going to pass through every single point in between those endpoints. We're now going to take a look at how this theorem could actually be used. Alright, so using the intermediate value theorem. So here's a question. Suppose we wish to determine, is any real number exactly 1 less than its cube? Well, if we were to translate this into an algebraic expression, we want to know, is any real number, let's call that x, is that equal to exactly 1 less than its cube? If we want, we can rewrite this as x cubed minus x minus 1 and then equals 0. So we want to know, essentially, does this equation have a solution? Well, let's throw this into our calculator and see what it looks like. So here's what the sketch of this equation here would look like. So I graphed x cubed minus x minus 1. So is it ever going to equal 0? Well, we can see right here that it is going to equal 0. So how do we really know that? Well, suppose we were to look between x values of 1 and 2. Okay, so this is a continuous function. All right, we know polynomial functions such as this are going to be continuous. So because it's a continuous function between these 2 points, notice that at 1 we have a negative y value, and that at x equals 2 we have a positive y value. So we know it's going to take on every value in between those, so it's guaranteed to hit 0. So let's jot that down. Alright, so understand first of all, guys, that you are going to be expected to write sentences pretty often in this course to explain your thinking, to explain or justify a certain answer. So please get used to that. So here is an example of the intermediate value theorem. So we say that the function changes sign between x equals 1 and x equals 2. Okay, so here's x equals 1, here's x equals 2. So there must be a point, which I'm just going to use lowercase c. There must be a point C somewhere between, and I'll put my C right there. There must be a point C somewhere between 1 and 2 where f of c equals 0. So the f of c equaling 0, that's what we needed to solve for. Okay, we can obviously see that there is a 0 here, but using some of the language from the intermediate value theorem, that's what it would look like.